adding decimals. Steps to add decimals. So the first step is to line up the decimal. And then we're going to add zeros to have the same number of place values to the right of the decimal. And then the last step will be to start adding by starting on the right. And then we're going to move to the left. So let's look at an example. So we have the supply voltage is equal to the sum of voltage drops in a series circuit. Find the total voltage output given the following individual voltage drops. So we have 2.7, 3.5, and 5.9. So we need to add all these. So the first thing we do is we're going to line up the decimal. So we have 2.7, we have a 3.5. Notice we line up the decimal, and then 5.9. Draw the line, and then we're going to add. Now we start, and we don't need to do step 2 because they all have the same amount of place values on the decimal to the right of it. So let's go by starting to add. We start on the far right, so we go 7 plus 5, which is 12, plus 9 is 21. So we put a 1 below, carry the 2 to the 1 spot. Now we're going to go ahead and bring down that decimal straight down. Now we have 2 plus 2, which is 4, plus 3 is 7, plus 5 is 12. And so we would say the total voltage is 12.1 volts. As we always want to make sure we include our units. So now let's look at another example. Example 2, solve for the following. So we have two numbers that we need to add together. So let's go ahead and write them out. Now we have this 0.634. Now with this other number, we go 0.07. So we've lined up our decimals. The next thing we need to do is add a 0. And we add a 0 here, so it's the same number of place values after the decimal for both numbers. Now we can start adding. We start on the far right. So 4 plus 0 is 4. 3 plus 7 is 10. So we put a 0 below, carry the 1. 1 plus 6 plus 0 is 7. And we're going to go ahead and bring down that decimal, and 0 plus 0 is 0. So this would be our solution to this problem. Let's go ahead and look at another problem. Now let's add these two numbers together. So let's go ahead and write 22.5784. Now what we're going to do is going to go ahead and place that decimal right below it. So we're going to go 0.801 to the left of the decimal, and then to the right of the decimal it's 40517. Now let's go ahead and start adding. Except what we need to do though is we notice that we only have 4 decimal places to the right of the decimal on the first number and only 5 on the second number. So we need to go ahead and place an extra 0 on the top of there. Now we can start adding. We start on the far right. 0 plus 7 is 7. 4 plus 1 is 5. 8 plus 5 is 13. So we put a 3 below. Carry the 1 over on top of the 7. So 1 plus 7 is 8. 5 plus 4 is 9. Now we have these decimals. We're going to bring that straight down. Now we have 2 plus 0 is 2. 2 plus 8 is 10. Put a 0 below, carry the 1 to the 100 spot. So now we have 1 plus 0 is just 1, 1, and then just straight down because we only have the 1. And then this would be our solution when we add these two numbers together. Now let's do one final example. Example 4, find the total voltage output in a series circuit given the following individual voltage drops. So we have 1.3, 1.8, 2.8, and 5.7. So let's go ahead and write all that out. So we have 1.3. We're going to make sure we keep the decimal lined up. 2.8 and 5.7. Let's go ahead and add them. So we can go ahead and just bring down that decimal straight right there at the beginning. Now we have 3 plus 8, which is 11, plus 8 is 19, plus 7 is 26. So we're going to place that 6 below, carry the 2 over to the 1 spot. So we have 2 plus 1, which is 3, plus another 1 is 4, plus 2, 6, plus 5 is 11. And so we have 11.6. And that would be our total voltage.